Good morning or good afternoon, everyone. I am Nina Gao from a Family Service Data Science team. So in this session, we are going to talk about how the data analyst supporting the policy decision of the new service, LIVEBUY. So let me introduce myself. So I joined the line in October 2020, and I joined in a data science center line. And then in the data science department too, I analyzed the line pay and also I did the data analytics of the line buy. Which is one of the line family service. And in a data science center, on top of the data science department, there is the ad data department, which analyzes the advertisement, and also the machine learning solution department, which does the machine learning product development, and also the machine learning and the ML and the DS planning team, which plans for the service issue solving with using the data science and the machine learning. And so let me do the quick introduction. So please imagine that if you are the data scientist and then you are in charge of the newly born service, and then you have to make an important decision based on the data analysis. You don't have enough data yet, and it's impossible. Probably many people think so. And also, you may want to bring the data from other services and use those data. However, then you have to face the issue of the personal information protection as well as the compliance. We instead use the data unique to line and to solve this challenge. This is the agenda of this session. First, I introduce the LIVEBUY, which is a new service that I'm in charge of. And then I'm going to explain the hypothesis that we thought important in the beginning of service and the background of it. And when we verified the hypothesis, there were multiple issues. So I will talk about how we solved them. And next, I told you that the data unique to line. So I will explain the Y features. And lastly, I will explain the result of the hypothesis verification as well as application examples to the services. So throughout my presentation, I hope that I can give you some hint to everyone how you can do the issue solving by the data analysis without having a lot of data. So now I'd like to introduce the LIVEBUY. So LIVEBUY was provided, had a pre-launch in November 2021. It's a live commerce service on the line, so the users can watch the live broadcast, and then with just a few taps, they can purchase the product they want. Like the talents, some have a broad programs to introduce the cosmetics that they love, or the musicians present their own goods, and so we have a variety of contents. And many cases, users received the broadcast notice from the LIVEBUY line account, official account, after they registered it, and then they move to the broadcasting page, viewer page.
And the live viewers can participate in the program through the chat function. The comments usually include feedback on the product, support for the performer, and questions about the size and the use of product. The performance also check the comments and sometimes respond to them, creating a sense of unity with the users. at the live buying, and this kind of the two-way communication is one of the major attractions. A brief description of the service growth. Since the service release, the number of monthly deliveries has gradually increased, growing 175%, 2.8 times bigger compared to the beginning and the end of this term. At the same time, the sales are increasing, and this is one of the most promising services in LINE's easy business in the future. Although the live buying as such, in the early years of the service, the company was supposed to make decisions on the important new policy. The section describes a hypothesis related to that policy decision. The hypothesis is that chat behavior during delivery drives product purchases. The truth of the hypothesis is was considered very important in determining the direction of the UI UX. My mission was to verify whether chat users convert into buyers and to help them decide whether to adopt a policy that encourages more chatting in their service planning. Indeed, as shown in this UI right-hand side, if the probability of the clicking buy is increased by the chatting with the one I've been waiting for, it is very attractive as a trigger for the service growth. Let's look at the result of the basic tabulation here. When the two groups are divided by the presence of the chatting, the users who chatted shown higher average purchase frequency and average purchase amount. We highlighted several programs, and regardless of the comments during that lives, those users actually commented, even though at once, and that is included in here. And then also for this the purchasing behavior after chatted, and that is the focus. And in every program, we have seen the same common result. And program 3, that was shown the most modest values. The average number of purchase and the average purchase amount were both about 12 times higher for users who chatted. Normally, this result alone would lead to many to believe that the chat prompted a purchase. But can we really take this result for granted? The answer is no. Here's a description of the problem and its solution. And the relationship between the problem and the solution is illustrated in this figure. The analysis I was in charge of was to come up with the solution to a single problem. And it was a difficult road with the solution creating a new problem. First, selection bias with respect to the aggregate result I just mentioned. Selection bias refers to an event in which a subset of subjects are selected from the overall population, resulting in a biased result. For example, compared to the others, a part of the group will have special tendencies. In case of the live buying, it is possible that the users who chatted were highly motivated to purchase in the first place, even though it's a part of the users. And the users do have the high motivation for the purchasing, and which may influenced outcome variables, such as purchase amount. The solution to this is a Rubin's counterfactual, hypothetical, and propensity score. The users who actually did the chat, and what if this person did not chat? And that would be the Rubin's counterfactual model. The red cell shows in the table corresponded to this. Z equal 1. And for the interventions and those users, without the interventions, and that can be considered. That's what it means. And at that time, the result by 0 will be this kind of the data. You cannot actually get it in reality because this is only a possibility. And what you'll be able to use will be something in the blue cell, the data who did not chat, and Z equal 0, and no interventions, and those user, and without the interventions, and this is the result. And for those two cell data, looks like irrelevant, and however, within the blue cell, and that is similar to the data in the red cell. And using this group of the people, the chatted users, what if they do not chat? And that kind of the atmosphere that will be able to create it. And so the users, the similar users would be considered as users with the covariances, similar covariances. Example of the covariances, including the number of a month of use in LIVEBUY, and the number of viewing hours per month, and the numbers of the registrations to seller's official LINE account. Now, using this, the Rubin's counterfactual, we have to correct we have to correct that this result, and propensity scores help us to achieve this. And first, we built a model that predict the probability of the user chatting based on the covariant. And the probability calculated for each user from this is called the propensity score. Of course, since it is a probability, the propensity score falls between 1 and 0. And differences between the means of the two groups by using propensity score can be corrected. It is clear that the effect of the chatting on average across the population can be estimated by weighting by inverse probability using propensity scores as shown in here. The effect is the same as when creating group of 2 while matching the ease of chatting.
So, when we try to assume the propensity score, we faced a new issue. So that was the cold start issue, cold start problem. So even though we wanted to build the model to calculate the propensity score, since the LIVEBUY it do not have enough data to train model. So there must be many data scientists who experienced the similar problems. So I, recalled that the LINE users are using the different services So that I thought I was going to bring the data of the services other than the LIVEBUY. However, LINEBUY, LIVEBUY. But however, we have to face the compliance issue. Also, that we didn't have enough time to know the data well. So I thought I had to I have to give up the analysis itself. But we are aligned, so we used the machine learning, and then we came up with the solution. So the solution is Y features. So now I'd like to explain the Y features, which is a very unique data to line. So this is the organization chart that I showed you earlier. The Y features was developed by the machine learning solution department. So data science department and the machine learning solution departments belong to the data science center. So for example, they collaborated in implementing the recommendation engine and also improving that. And so machine ML and DS planning teams connected these two departments well. So we received the great advice on Y features usage. Y features was specialized features of the Z features, which actually had the line user service usage situation for the machine learning and analysis purposes. In Y features, line news and the stickers, and then the reaction to the ads are available. So over 30 of data are available. So Y features was developed in order to solve the two issues of the Z features. So the problems are that the D features are, interpretable and very extremely sparse. So these problems were solved in the process of the generation of the Y features. So this is the data flow from client. So which news was read or which stickers was bought, and such user log data was sent to server. And then from that, so the approved data only was filtered and then transferred to the information universe, which is the analytic environment. So the usage situation of the different services were stored by MID, and so Z features is extremely sparse and stored in a very sparse state. And also the title of the news or the price of the stickers, such as such content informations was transferred to the client and then stored as a Z features meta. And then through representational learning using the graph convolutional network, dense feature vector is generated from two data. The graph structure, so user nodes and item nodes exist. So which is the user item graph. So that this is very similar to that. So what features we got like that could not be returned to the Z features or the user logs. So therefore, we overcame the compliance issue.
For the data set used to estimate the propensity score, and that is shown in here figure, and whether the chat or not, and that would be 1 or 0 flag. the present, and that's explain about the presence of the absence of the chat, and which is teacher data. And the Y features as a covariant. With the Y features, trend scores can be estimated as a dense vector of easy-to-handle data from more than 30 services behavior logs per user. Specifically, the vector size is kept to about 60 dimensions for each service, which is sufficient for data frame format. Now, let's look at the result of the propensity score analysis using Y features. First, let's look at the model verification. L2 regularization was used in the model to predict the presence or absence of chat. Logistic regression model. We also tried the machine learning models, such as a render forest, but this model gave the most stable result without calibration. The figure on the left shows the ROC curve, and we managed to meet the criteria with an AUC of 0.7 or more, which indicates the fit of the model. The figure on the right shows the distribution of the predicted propensity scores, and with the blue indicating users would chat, and orange indicating users do not chat. We judge this to be an acceptable result as well, since there is some overlap, but the peak of the distributions are different. Finally, the distribution of the covariance is also proportional before and after correction by the propensity score. Comparison is high. The difference in means of the standardized covariance between the two groups was used as a matrix. The difference in the means of the standard here the blue dots are the value before correction by the propensity score, and orange dot are the value after correction. And after correction, the difference is within plus minus 0.2, and this means two groups distribution of covariate is approximated by a propensity score. It is expected that the propensity score will correct for the difference in the mean between the group of users who chatted and who did not chat. Looking at the result of the program 2, with regards to the average number of purchase, the left was about 16 times or so before the corrections. After the corrections, the left was about 10 times differences. And also, the average purchasing has been corrected from 14 times to the 6 times. And there was a bias at the initial cases for the chat users. But it seems still, chatted users show a higher lift for the product purchase matrix. From this, we concluded that hypothesis, chat behavior during delivery drives product purchase, is supported. Finally, how the result of this analysis is applied in the service, which I would like to talk about it. Mutual communication facilitated by the analysis result. In order to do so, the UI has been improved. Especially when a new comment is entered, the screen scraps up to that comment. And that was the specification. And it would roll to that comment. And we have added an icon with the down arrow circled here on the right. So which will jump to the latest comment only when it is pushed. The improvement make it easier for presenters or performers to check comments and communicate with users. In response to the result, LIVEBUY is now also encouraging chat through this program. The program is designed to increase the users' engagement by featuring comedians who are likely to comment on the program as they interest with each other. Other programs featuring well-known musicians, the chat allows for mutual communication, much like an offline fan club event. With the easy-to-chat program structure, LIVEBUY is increasing the number of purchases of products. Let me conclude with the review of this session. At the very beginning, I have asked you to participate in the new service, and then also with the small numbers of the data, and you have to make decisions for important policies, and that's what I have asked you to imagine, right? And then with the small number of the service data made and depth analysis, such as the model learning difficult, and interpretability was a compliance issue when trying to use the data from the other services. And machine learning solution office actually developed the Y features, and it was a solution for these issues and helped support the key hypothesis chat behavior during the delivery drives product purchase. In this way, in the line, the Data Science Center is working together to solve the challenges of services. Thank you very much for your attention. Nagao-san, thank you very much.
ここからはプラストーク
So now we're going to have a plus talk so that we can ask the questions to the presenter to deep down the presentation contents. And we'd like to get as many questions as possible from the audience. And you can use the question mark button to post your question. So Kazuki Yoshi from Yahoo is the interviewer. So please introduce yourself. Yes, I'm Yoshi from Yahoo. At Yahoo, I belong to the data science department. So the data accumulated in services are used across the entire organization. So that's what we are doing. And also the user vector data is the one that I'm making. So nice to meet you. Thank you very much. So do you have any question that you'd like to ask? At Yahoo, like user vector data is used as a feature of the machine learning at Yahoo. So we haven't used it as a data analysis purpose. So it's a new thing. And so for the purpose of the data analytics, so you use vector data. But how could it be generalized? I mean, is it possible to use this approach in other services? Yes, the generalization of the vector data. So as for that, I think it could be pretty generalized. But for example, it depends on the sphere of analytics. So this time, this is the analysis of the feature of the chat activities, but the line itself is a messenger app. So the chatting or making a comment, such actions are relatively easy to collect the data on with that line up. So for So therefore, for the analysis of this phenomena, it fit better. But if it's just a decision on whether to buy or not, if we use this feature for that kind of analysis, probably it may not fit so much. So we have to verify the model and in order to determine whether the particular feature can be used for this phenomena, but not that phenomena.
Thank you very much. It's not used. It can be used for in every cases. However, you before that you have to analyze for which case that you can actually use this analysis. Yes, thank you very much. And next question. And for instance, in the live buying, if you accumulate the more data in the future, and then also if you want to analyze for the hypothesis in the case, and those using the covariant and that has been accumulated in the live buy and do the score analysis, or can we actually do this in a way that we have done this time, or can you actually do it both? How do you view on that? For this question, my answer would be the light buying data volume is going to be increased in that case, that the feature, the volume of the features, the light buying data that we would like to create it, because for Y features, to avoid the compliance issue, and from that perspectives, interpretability that has been actually avoided, and that's why we said we are not going to use it. But in terms of the service, using the service data, and then for this service, what would that be, and then also who is our users, and we'll be able to understand that, and that is very important. And therefore, once the light binds the service data volume is increased in that case, we will create the data, and then also if it does not fit in there, and in that case, we will combine with the Y features for the analysis, and that would be good, I think. Thank you very much. I did understand well.
So next question. So you conducted analysis. So the person who does the analysis and also the decision maker to change the UI or UX are not always the same, are not often the same. And so in order to make a quick decisions of the on the service based on the data analysis in line, how you organize your team so that you can make a quick decision based on the data analysis. In case of our live buy of the line, we have the analysis team, and within which the product manager actually get involved in the discussion. So the product manager ask the question about the issues of a certain product to us. And so then we design the service in order to solve the problem. And then we make a suggestion like, we should push the chat like this. And so we make such a proposal. And basically, the analysis and also the business department should be closer. There shouldn't be a big gap between the two. So therefore, I myself very spontaneously make some proposal to the business unit and talk to the person like product managers. So we try to make such an environment. So that's what we are doing outline. Thank you very much.
Thank you very much. And as a one team together, we should, in agile manner, and we should come up with the solutions for the analysis. And you do have such organization. That is great. Thank you very much. And UI improvement based on this result of the analysis, in order to measure that the values. And have you conducted the A/B test? Do you have that result? Yes. To be honest with you, we have not done the A/B test yet. And right by itself, it's launched quite short time, right? And it's been just released, and therefore A/B test environment is not ready yet, to be honest with you. And line and A/B test framework at the machinery department, and they are proposing, and in many services they are using that or implementing that. When the service grows or matured, and a UI/AB test is going to be done by the regular framework, and they verify, and UI implement was good or not, and that kind of the result is going to be reviewed. And in some cases, it will go back to as it was before. So I think that that is a line style. And therefore, for the future, we would like to conduct that for the LIVEBUY. And that is our status currently. Thank you very much. So I'll be looking forward to seeing that. Thank you.
そうですね。
Yeah, this time you made the model to predict the propensity score. So, well, actually, the which kind of users has the has a high propensity score, and did you do such qualitative analysis? Yes, for the qualitative analysis, it's the one that we are going to move forward. And idea is that there's a concept of the commitment in the behavioral economics. So you declare what you are going to do, and if the declaration exists, then that there is more propensity that this person actually engaged in that action. Like so I've been waiting this for a long time, and by declaring that, by saying that, that it's likely that we think that it's likely that the probability of purchase will go up. So therefore, the contents of the sentiment of the comments and the contents of the comment will be categorized going forward. And by doing so, we'd like to find that the comment which will be highly likely to lead to the purchase. Thank you very much.
そうですね。
And let's say something else. Using the other services log data, and you have created the by features has been created, and then make it to the covariant, and that was approach. And however, the data is coming from the other services, and that was used for covariance for this propensity scores. How did you verify that to use that for this covariant can be used or variable to use it for this case? Is there any such foundations? And that was my little concept. And in terms of the covariant, whether it is effective for that forecast of that propensity scores, and only the qualitative aspects that we can actually see, because that the data is maybe the data type from the line news, and in the case, but the feature, the white feature is the meaning what, in which we don't know, and therefore for the vector data, and whether it can be effective or not for forecast or predictions, and that would be the limit. To that extent, we can actually see it or not. And thank you very much.
So white features, the data white features could become big, right? Because it relates to the many users, and also sometimes it may be harder to use. So in order to retain such data, which kind of a data warehouse you are using? For example, AWS Redshift or Google BigQuery, or there are many data stores. So in line, what kind of data stores are you using? So we have the on-premise environment at our companies, like a Hadoop cluster is the one that we are using to do the parallel processing and to process the data. So we have that such a process flow. So we used the by features this time, and pre-processing time didn't take so long, and so we thought this data was very easy to handle. So That was my feeling. Okay, so so you have a data infrastructure. Good. So so I made a lot of new discovery from this session. Thank you very much. Thank you very much for your session.